Okay, so today we're going to be talking about air masses and fronts. All right, so air masses and fronts. Well, first we're going to talk about the four different kinds of air masses. Okay, air masses are just large chunks of air that share similar characteristics. So we're going to be grouping these two by two different things. Number one, where they're coming from, and then number two, what temperature are they bringing? So the four types of air masses are maritime tropical, maritime polar, continental tropical, and continental polar. So if we take a look at these, we're going to break them down. We really see there's two differences. The first word is either maritime or continental. And the second word is either tropical or polar. So when we take a look at maritime, where are the maritime ones coming from? Well, they are coming from here, maritime tropical, here, maritime polar, over here, maritime, another maritime polar, and another maritime. So the key is that maritime is talking about over the ocean, okay? So if it's coming from over water, it gets that maritime tag. What do you notice about tropical versus polar? Well, the polar ones are where? Closer to the pole, the North Pole, and the warmer ones, the tropical, are coming from closer to the equator. So the key here is that maritime tropical is going to bring warm, moist air, okay? Because it's going to pick up, if it's coming from over water, it's going to pick up lots of water vapor as that water evaporates. The sun hits the ocean, some of that water evaporates, and that, that's in the air. So it's going to be, the key is that's going to be bringing that with it. And if it's coming from the equator, it's going to be warmer. So maritime polar are cooler air masses, and they also bring with them lots of water vapor in the air. Then if you take a look at the continentals, the continental polar is coming from up here, the northern, near the poles, and then the continental tropical. There's only one small one down here. This is mostly focused on the United States, but these terms, or excuse me, North America, rather. But these terms really do apply to any hemisphere, anywhere in the world. So if it's coming, again, over land, it's continental. If it's cold, polar. It's warm, tropical.
So on the notes where it says the maritime tropicals and then the first blank right there's air mass from over water. So does that you put the Martin time or whatever?
We're going to go over each one. So you may have just
Okay.
been a little bit ahead. I was just kind of going through and breaking down the vocab. So there's going to be a slide on each one. Yep. Thank you. All right. So again, just to focus on maritime tropical, this is warm, humid air masses that come from near oceans, near the tropics, near that equator. For the United States, they're going to form over the Gulf of Mexico and the Southern Atlantic Ocean. So off the coast of Florida, here in the Gulf, or over here in the Atlantic. Again, it's coming from the south, so it's warmer. So it's bringing that warm, moist air up. Now, in the summertime, this is going to bring hot, humid weather. So these are the days that you really don't like. When you go outside and you feel like that heat just hits you in the face because it's so, the air is so thick and it's so hot. These are really miserable in the summer. We don't want to see a maritime tropical air mass move into our region. In the winter, though, these bring heavy rain or snow. So a lot of the snowstorms that can come up and be really bad in terms of snowfall can come from the Gulf of Mexico. In the winter, they bring that warmer, it's not as warm, but warmer air and lots of humidity. And then when it goes further north, it cools and it starts dropping that out as snow. So these can be some pretty bad snowstorms, kind of like we just had. Any questions about maritime tropical? All right.
No.
So maritime polar, this mostly affects the North Pacific and North Atlantic. This really doesn't really affect most of the United States just because there's not a lot of ocean that touches our country from the poles. So These air masses affect the West Coast more than the East Coast. So if you think about like Washington State or Oregon, you know, Seattle is really known for the rain that it gets a lot. You know, Portland, again, that's because these cool, humid air masses are coming from the North Pacific and North Atlantic Oceans, North Pacific in their case, and it's bringing that cool, humid air. So they get lots of fog and rain on a quite regular basis. These don't usually affect us very often here in Indiana. Okay, continental tropical. These are hot, dry air masses. And in the summertime, they form in the southwestern US and northern Mexico. These tend to be smaller air masses just because there's not as much land mass for them to form over. We're going to see that these ones that come from up north can be quite large, but you see there's not a lot of land mass in Mexico. It gets real skinny here. So these air masses tend to be quite small and don't affect a very large area. They bring hot, dry weather to the south. So they come up, hot, dry air. So you think, you know, where are our deserts? You know, you think southwestern United States, Texas is very hot, New Mexico, Arizona. So they get a lot. Those are mostly affected. Nevada, you know, a lot of desert Nevada. So these areas get these tropical continental air masses that come up and keep it real hot and dry. Next, we have continental polar. Continental polar air masses form over central and northern Canada and Alaska. You see up here, there's much more land mass, so these can tend to be much larger than their partners, than the tropical continental. So they bring cool and dry air. In the winter, they bring clear, cool, and dry air to most of Northern America. So here's the thing, is that we just experienced one of these continental polar. In fact, it was, you know, the super cold temperatures and stuff like that. You remember when those came down? And they're still kind of hanging around. But these are large continental polar air masses. It's why, you know, even though it snowed Monday night and Tuesday morning, it really was cloudy during the snow, but then the next day it was crystal clear, right? So, you know, woke up on Tuesday, the sun was shining and the air was clear, no clouds in sight. This is because a continental polar air mass had moved in. Again, that high pressure, I don't know if you got a chance to see yesterday's video yet or not. We talked about high and low pressure. So a high pressure continental polar air mass moves in and it brings cool, dry air. In the summer, storms may occur when continental air masses move south and they meet the tropical maritime air masses that move north. So I don't know if you know too much about this area, but like Oklahoma, Kansas, you know, this area in here, this is Tornado Alley. This is what they're talking about. So what happens when you get a big mixing of different air types? So you have these continental polar air masses, big, cold, dry air masses moving south, running into warm, humid air masses coming from off the oceans moving north. They collide, and when that air mixes, that you get those severe storms. And so that's why you get lots of tornadoes and stuff like that in this area. They can be quite large because these different air masses, when they interact, they get pretty violent. Or they can, depending. All right, so how do air masses move? They are mostly pushed in the United States by the prevailing westerlies. So this is came from the wind web quest from yesterday. So you guys looked at the global wind patterns, and if you didn't, just take a look here. This just shows us the different wind patterns that we see across the globe. Yes, hi Owen, I'm teaching class. So you can see up here in the northern hemisphere, we have the southwesterly winds. Winds are named for where they come from. So these winds are coming from the southwest and they're moving northeast. So the prevailing westerlies is kind of how we summarize that. And they push the weather from the west to the east. So here in Indiana, if you want to know what the weather looks like, you might look a little bit west a little bit south of us. So if you want to know what the weather's going to be like in a couple hours, you might look to like Indianapolis. If you want to know what it's going to be like tomorrow, you might look at some of the weather that, you know, states further west are having, because that's usually what we're going to get. Okay. So we push the air from the west to the east, like I said. Okay, just again, sorry, I didn't mean to not have that up there. From the southwest to the east, railing westerlies. So obviously you have these different air masses moving around. They're going to run into each other like we just talked about. Okay, and when two air masses run into each other, it's called a front. So this is a term you probably heard a lot more than those other terms that I was talking about with, you know, the different air masses. But you've definitely heard the weather people talk about, oh, a cold front's coming in or a warm front's coming through. Now you may not know, you know, quite what that means, and that's what we're going to get into, what's really happening as a cold front or warm front moves through. But hopefully you're a little bit more familiar with these terms. So this is again a collision, and when they collide, we often get storms. And this is the key: the weather is going to change. Okay, that's very big. Weather changes, so it's going to be one way to start. The front's going to come through, and that's going to change the weather. So it's not going to be usually not going to be the same as it was at the beginning. Fronts vary in size. They can be from about 15 to 200 kilometers wide, and they can extend as up to much as 10 kilometers up into the troposphere. Remember, all weather happens in the troposphere, that bottom layer of Earth's atmosphere, the one that we live in. So all these fronts, all this Jurassic weather is all happening within the troposphere. Now, the kind of front that develops really depends on the characteristics of the air masses and how they're moving. Basically, what that means is what type of air mass is pushing out what type of air mass. That's going to determine whether it's a warm front, cold front, or the other two types we're going to talk about here in just a moment. So, just like there are 4 air masses, there are 4 types of fronts. The first type of front is a cold front. We also can have warm fronts. We can have stationary fronts, and we can also have what's called an occluded front. And we'll talk about this one. This one you probably have not heard about. Probably heard about the top 2, may have heard about stationary, but definitely probably haven't heard about this. So let's get into these. All right, how does a cold front develop? Well, what we need to understand about how the air is going to interact, we really need to know about how the characteristics of the air are dictated by their temperature. Okay, cold air is very dense. That means that there's a lot of air packed into a very small area. So that's going to increase its mass, and that's going to cause it to sink. This is why the basement of your house is usually the coolest room in the house if you have a basement, because all that cold air is going to fall to the bottom. The reason for that, again, is because it's more dense. Now, warm air is less dense, okay? It has heat, and heat is energy. So those molecules spread out, they take up more space. So you spread out the mass, that makes it less dense. Things that are less dense tend to float or rise. That's why warm air rises. So the top floor or the attic tends to be the warmest place in the house, because that's where all the heat is going to rush to. The reason that I have to point that out is because that's going to dictate how these air masses are going to interact. We have to remember the cold air is going to be dense. It wants to stay close to the ground. And conversely, the warm air has a lower density, and it's going to want to rise. It's not going to stick to the ground very easily. So in a cold front, we have a moving cold air mass runs into a slower moving warm air mass. So it's going to start off being this warm, humid air. Then the front is going to come through. This cold air runs into it, and it wedges it out. The key here is that the denser air, the cold air is denser. It's going to slide beneath the warmer air. And that's going to cause some of the warmer air to get pushed up into the atmosphere. Now, again, as you get away from the surface, what happens to the temperature? Remember, snow-capped mountains. It's colder the higher you are in the troposphere. So as that warm air gets pushed up into the troposphere, It's going to start to get colder. That's going to cause it to condense, get closer together, and then it can fall out as rain. So it might condense into clouds, and then it might condense further and cause rain or storms. But the key is this cold air is coming in and it's pushing out this warmer air, but it's doing it by wedging beneath it and pushing that warmer air up. So you really got to pay attention at what these arrows are doing here. So the warm air is being pushed out by the cold air. The cold air wants to stick to the ground. That warm air gets shoved upward. So also the warmer air can hold more water vapor than colder air. It's because the molecules are spread out. There's more room for that water vapor to get, there's more room for it to turn into water vapor, excuse me. Depending on what season it is, it might be rain or it might be snow. And cold fronts are the faster moving fronts. So they move quickly. Think about, in the fall, sometimes you wake up in the morning and it's kind of warm and muggy. So you kind of put on those summer clothes, you're still kind of in between, but then you go to school or you go to work and then you get off and you step outside and it's real cold all of a sudden. Well, that means a cold front has come through. Started warm and humid, you might get some weather, you might get some clouds, but then it's going to change. It's going to change, and after it's going to be cool and dry. So again, we're starting warm and humid. Then we get the front coming through, might get some clouds or rain or a storm. And then after, it's going to be cool and dry. So what we just had with the snowstorm was a cold front, okay? Again, it's not like it was warm before. We're talking about just the differences between the two relative to one another. The air we had before was slightly warmer and it had more water vapor in it. That cold, high pressure air mass came through from the continental polar one, came through, caused lots and lots of snowfall. And now after, it's clear and cool outside, right? The air is pretty dry for the most part. There's not a lot of clouds and the sun is shining. It's still cold, okay? Trust me, I was outside shoveling snow a lot yesterday. It's still cold, but the sun was shining again because that high pressure, that sinking air, not a lot of clouds. All right, so that was cold front. Now let's move on to warm fronts. A warm front is just kind of the reverse, okay? You have a moving warm air mass that collides and pushes out a slower moving cold air mass. So the key here again is that the biggest difference between this one and the last one is that in this case, the warm air is less dense. And again, it wants to rise. So when we look at this diagram over here, we have this cooler, denser air, and it's going to hug the ground. So this kind of has to lean on it and kind of squeeze it out of an area. So that warm air, because it can't get underneath like the cold air did, it's not going to wedge it up. It's just going to kind of squeeze it out and push it slowly out of the area. It's because it can't get underneath that it's actually a little bit slower moving, because it kind of has to push down from the top in this direction. And then that cooler air mass will slowly be pushed down to the area. So if that warm air is humid, you might get some showers or light rain, but this is not your severe storms. Again, because there's not as much uplift. When we were looking at the cold front, that cold air really wedged up a lot of that warm air. But in this case, it just has to push on top. So you get some clouds, maybe some light rain here, but not as much with the cold front. If the warm air is dry, again, you just might get some scattered clouds. Might not get any rain at all. And again, we get a change in what the weather is like. It was cooler and drier, and after the warm front passes through an area, it's going to be warmer and more humid. Okay, so warm fronts are going to, again, change the weather, but in this case, change it to be more warm and more humid.
That's what sucks in the summertime. It rains and then it gets really humid afterwards.
Exactly. It's like the rain didn't even help. Those are exactly the days when a warm front is coming through. It's just going to be stickier rather than better. So thank you for pointing that out. All right, so that's it. Oh, sorry, was there one more? Oh, in winter, warm fronts can bring snow. So again, snow is a hard thing to think about, but when it's snowing, it's actually technically warming the air again a little bit. So warm fronts, if they have a lot of moisture in them in the winter when they come through, they can have a little bit of snow. All right, the next type we have is stationary fronts, and you might be able to guess by its name that sometimes air masses meet, but they don't have enough force to push past one another. Maybe they're just, going like cars do, perpendicular to one another, or excuse me, parallel to one another, or anti-parallel because it's opposite directions. But anyway, going opposite directions, but they're not running into each other, so they're not really pushing past. This creates what we call a stationary front. So where that warm air and cold air are meeting, you might get a little bit of water vapor turning into rain or clouds. So you might you think about those days where it just kind of gently drizzles for like the whole day, or maybe 2 days, or it's just like real foggy for a whole day. That's because a stationary front has kind of formed there. The weather's not really going to change that much. It's going to be kind of consistent. And depending on where, if you're right on the boundary, again, you might get some drizzling, some light rain for a while, or just some fog. That's really it for stationary front. Not much is pushing, either way. And then we have the weird one, and this is the occluded front. Okay, the occluded front is actually two fronts kind of running into each other. Is the easiest way to explain it. So we have to remember that warm fronts, because of the densities of the air, the warm fronts move a little bit slower. So sometimes you have a warm front coming through an area, and then you get a cold front that moves a little bit faster, that kind of runs in the back of it. So this is what we have when we have an occluded front. This is also the only one that has, that has 3 air masses. So you have cool air being pushed out by warm air, aka a warm front, right? You should kind of recognize that. If we were to go back, you would see this almost the exact set of arrows and lines. But then you have a cold air mass that moves faster, coming in and hitting it from behind. So it's really a warm front that gets run into by a cold front. And what happens is over a couple days, that warm air can almost get trapped. You see how it's not even touching the ground? And that causes a lot of uplift. A lot of that warm air gets pushed up very quickly. So these can be some decent storms, because that warm air gets wedged in between, gets pushed up in the atmosphere, cools, condenses quickly, and get rain or snow. Okay. Now we're going to talk about cyclones and anticyclones, which is just another fancy way to talk about the air masses. Again, another fancy way to talk about high and low pressure, but it's important to understand. So warm air at the center of a cyclone rises, the air pressure is going to decrease. So this is a low pressure, right? Low pressure, the air is spread out, it's warmer, the molecules have more energy, take up more space. That causes its density to go down, so it's going to start rising. Now, the winds in a cyclone spin counterclockwise in the northern hemisphere. They spin clockwise in the southern. So this is an interesting just way. It's really dependent upon how something called the Coriolis effect, and how the winds are being pushed by the motion of the planet, basically. Okay, so it's going to cause it to spin one way in the northern hemisphere and the other way in the southern hemisphere. So as the air rises in a cyclone, it cools and it forms clouds and precipitation. So it's going to be stormy weather. The cyclone. The winds spiral outward from the center of an anticyclone. So this top part is about cyclone. Now we're talking about anticyclone. So they spin outward from the anticyclone, and they move towards the areas of low pressure. So again, things want to move downhill. So anticyclones are high pressure, cyclones are low pressure. So that's downhill. The high wants to move towards the low. And the winds in an anticyclone spin clockwise in the northern hemisphere. So these two also spin opposite directions. Now, what are giant cyclones? Giant cyclones we call hurricanes, okay? So what's happening here is this is a very, very low pressure in the center. So actually there's two hurricanes listed here, okay? So there's one right here and there's one right here. And we can see those spiraling clouds, right? And what we need to understand is that this low pressure is bringing the air at the, inward, and it's spiraling, okay? And it kind of spins, and it's a very, very, these cause widespread damage. Hurricanes are getting worse. The ocean is warming, and as that ocean warms, that causes the pressure to be even lower, and the lower the pressure, the faster the winds. So as you heat it more, that's going to decrease the pressure even more, and it's going to cause more severe hurricanes and more frequent hurricanes as well. Now, anticyclones are high pressure, so the air is sinking. Because the air is sinking, you're not going to get clouds, you're not going to get rain. And they want to move out towards areas of lower pressure. So again, it's moving down and out, so that this is not going to be your stormy days. These are going to be your clear, cool, usually drier days. It inhibits rain and clouds because the air is sinking. Okay, and usually this is where I have you draw these symbols, because what we're going to start to do is we're going to start to look at weather maps, and we need to know how to look at the fronts on a weather map. There's no good way for you to do that in words, so just pay attention and follow along. We'll just have to talk about it. So on a weather map, a cold front is a blue line with triangles that go in one direction. And the key here is that the side that the triangles are on tells you the direction the front is moving. So again, you see the warm air mass being pushed out by the cold air mass. That creates the front, and the cold air mass gets blue triangles on its line. In a warm front, we have warm air pushing out cold air, and on the front line, you get a red line with semicircles. So if you have color, sometimes these can be black and white. So again, you just got to look at the symbols. Triangles for cold, semicircles for warm. Remember, a stationary front, neither one's really pushing past one another. They're just kind of meeting and touching. So you have a different color, a multicolor line, blue and red, with blue triangles going in one direction and red semicircles and going in the other. So if you see them in opposite directions, that shows you they're not pushing past one another, they're just touching. These two are all in one direction, so they're moving, but this one's not moving. Then we have the occluded front. If it's in color, it'll be a purple line, but you can also tell because it has both triangles and semicircles in the same direction. So that's how you know it's an occluded front. And it's usually not, you might see these lines run together because all along the front, there might be different things happening at different points. So you might have a cold front that turns occluded, or cold front that turns stationary somewhere else along that line. So you're going to see these used a lot together. Okay, we don't need to do review. So I'm going to exit out of this. The review's there if you want. It just talks about the notes and stuff like that. Okay. So what I would like you to do now is I would like you to switch back over to the class and open up this student manual for reading weather maps, because that's what we're doing. We're going to be heading into. Okay. So if you open that up, this is a resource for you to use. I'm not going to go over all of this because this just reviews everything that we've talked about, talking about air pressure and weather and stuff like that. So if you took a look at the lesson yesterday, we looked at the air pressure maps. These are the isobar lines Remember, when the lines are close together, that's going to be strong winds. When the lines are farther apart, that's going to be gentle winds. It just shows areas of equal pressure. So it's a way that we can look at how the weather's going to change or be moving and things like that. Also on this map, you'll see some of those front markings. Here's a warm front with those semicircles. Here's a cold front behind it. So this could, eventually turn into an included front. Who knows? Okay, you have some two cold fronts down on this side. But again, this is just a lot of good information. This is talking about exactly what I was talking about with the pressure. When they're close together, you get stronger winds. Okay. This also reviews the high and low pressure system. So this is just a really good resource. Okay, here are the anticyclones and the cyclones. It shows you how they interact. So this is a really good resource to go through. Again, here it's reviewing the 4 different types of fronts. Okay, but what is new for us is this page right here. Okay, or these last 2 pages rather. So weather maps are put together by lots of different weather stations. You get data from all these different weather stations, and then you read the data and what it says, and you can kind of apply what you know to read and interpret the weather. But each weather station is going to report its data using the same method. Okay, they're not going to use like all these words and read out that's just too long. So meteorologists and stuff like that, they want a quick, easy key that they can read to look at the different weather stations to see what the weather is doing. And they also use, nowadays they use a lot of computer models and modeling and stuff like that. But anyway, if we're looking at a weather map, we need to be able to read this weather station symbol. So the weather station is shown in the center. And the center circle is actually going to show you what the sky looks like. And if we look on the next page, we scroll down a little bit, this is what the center of that station can look like. It can have nothing filled in, which means that it's clear skies. Yeah, I know. It can be, have a quarter of it filled in, and this is scattered clouds, approximately 25% cloud cover. It could be half filled in as partly cloudy. 3/4 of the way filled in is mostly cloudy, and then if it's all filled in, those are the overcast days where you can't even see the sky. If they're reporting at night or they can't see the sky because of fog or something like that, they might put that symbol, or if they just don't have the data. Okay, but mostly you're going to see just these top sets of symbols, clear, quarter, half, 3/4, and overcast. So that's that center circle right there. And then it has some numbers around it that mean different things. So the number in the upper left is the temperature, usually in degrees Celsius or degrees Fahrenheit, but you got to pay attention. Usually degrees, in the United States, it'll be degrees Fahrenheit probably, but in other countries, Celsius. Then the bottom left number is the dew point. So that's the point of the temperature at which water vapor in the air will start to condense and turn into, liquid water and kind of show up on stuff as dew. So in this station, it's showing us the temperature is 57. If it were to drop 1 degree to 56, that water vapor would start to condense. In the upper right, they have the pressure usually, okay? And then right below that, they have the pressure trend. So again, yesterday we talked about if the pressure is increasing, that means the weather is improving, clear, cool skies are coming. But if the pressure is decreasing, like this -6 means it went down 6, that means that a warmer, lower pressure system is moving in. You might get some rain or storms, okay? And it does tell the weather using the symbols here. So off the left, you see the weather, and you can look right here and see all the different symbols from, slight rain to, they have everything here. So the 3 dots right here means moderate rain, continuous. So it's a rainy day right now. We can see that the pressure is dropping, right? So that means that it's falling, low pressure, and that's backed up by the fact that we can see 3 dots. It means it's got some moderate rain. The last bit of information that they're going to tell you is the wind direction and the wind speed, and that key is right up here. Okay, the line is going to show you where the wind is blowing from. Okay, winds are named where they come from. That's really key. So the wind is blowing from the northeast. In this example over here, the wind is blowing from the northwest. Okay, so the key here is that it's where it's blowing from. That means it's blowing the other way. So the wind is moving, in this case, in our key over here, it's moving to the southeast. In this one, it's moving to the southwest. Okay. If there's no winds, you just don't get a line. It just that's indication that it's calm winds. And then it also tells you the speed. So a half line or a half dash is 5 knots. A full dash is 10 knots, and a triangle is 50. And you just add them up using that system. So in this case, we have 50, 60, 75. So this wind is blowing from 75 knots from the west. So it's blowing to the east. Okay. Now, this is a key that you're going to have use of. Now, what are you going to use this information for? Well, what we're going to be doing is, if you go back to the class, I have it open already, but if you go back to the class and you click on, we have two things left to do for today. We have this, the weather station, weather maps and symbols one, and then we have this one right here. So if you click on this one first, it's going to open up and look like this. And what we're going to do is we're going to use this key, the key that we had from right here, and we're going to decode, use this information to decode this weather symbol. Now, I can't split it on my screen to show you both side by side, so I'm going to be flipping back and forth. But remember, if you have your mouse over a screen and you hold that Windows button and click on one of the arrow keys to the left or right, that'll move that to half that part of that screen, and then you could have them side by side. I suppose I could share my whole screen. Let me do that. That way we can have them side by side. Let me share my whole screen. Stop share. Share screen. Just gonna give you my whole screen. Okay, so again, I'm going to take this, I'm going to keep it separate. I'm going to hold down my Windows key and hit the left arrow, and you see how that moves that to the left. Actually, I want this one on the right. So I hit the right arrow, so it's over there. Now what I can do is I can hit this one to the other direction, and it splits my screen half and half. Okay? Can you see both parts?
Yeah, I can see both parts.
Okay, sweet. All right, so you can read that below at the top, but it's just stuff I talked about. So I'm gonna jump right down here, and we're gonna start looking and decoding this weather station. Okay, so the question here, number one, it says, what direction is the wind blowing from? Okay, well, again, the direction depends on where that line is coming, and that tells us where it's coming from. So in this case, the line is to the lower right, bottom right. So I can't draw on here. I normally put this on the board, but you know your cardinal directions, just that cross. The top is north, to the right is east, down is south, and to the left is west. So never eat soggy waffles, or however you remember it. But in this case, it's moving down and to the right. So I know that is blowing from the southeast. Number two, what is the atmospheric pressure in millibars? So again, where's the pressure? It's in the upper right-hand corner. So they're reporting 1045 millibars of air pressure. Number three is asking us, how does the dew point compare to the air temperature? So this is asking us about two numbers. So to go back here, the temperature is the upper left, the dew point is the lower left. So the temperature in this case is 45 degrees. If we look down to bottom left, the dew point is 29 degrees. So we can see that the dew point is 16 degrees lower than temperature.
So you put that it's 16, or the difference is 16.
You could, or just say 16 degrees lower, something like that.
Okay.
And then number four says, what is the cloud cover? So what do you see? What is that station reporting for cloud cover? Cloud cover is down here. Here's the station.
And it's saying that it's a Overcast.
It is overcast. This is all filled in, so that means it is a full cloudy sky. It's overcast. Very good. And is there any precipitation at this weather station?
Um,
Look here, I see 2 dots. What does 2 dots mean? Let me zoom in a little bit, maybe that'll help. I don't know if you can see it, but 2 dots means slight rain continuous. So yeah, there is precipitation. There is some rain.
okay, my last question like disappeared. I don't know how.
Okay, just add it on after number 4.
What was it?
The question is there any precipitation?
Okay.
Good, that picture is not showing up, so that'll be make this second part real easy to do, but we'll work through it together.
And it said, is there any precipitation? And it was
The slight rain continuous, so yes.
so yes.
Slight rain.
Okay.
All right.
I don't know how that happened.
So it's when you take a document from Word and convert it over into Google Docs, sometimes things don't work out right, like we're seeing with this picture, because this picture is not showing up. So we're just going to do the best we can and answer the questions that we can. So let's just jump to number. Let's just talk, let's just skip this. You can skip this page. This page is not working. We're not going to be able to do this. The key would just be right here. We can talk about it. Right here, I see a line with arrows in what direction. So what front is that?
It's a cold.
It is a cold front. Good. There's also a cold front right here. But if you notice, what happens to the cold front right in this bottom area right here?
It starts to get warm.
It does, and it becomes what's the front where we have semicircles? These are supposed to be semicircles in one direction and triangles in the other.
A stationary front.
Yes, so we can see it's moving on one part, but over here it turns stationary. This part of the front is not moving. Good. And the H stands for, it's a pressure, H for high pressure. Okay, so this is the high pressure pushing this cold front. That's where the cool dry air mass is. Okay. It's supposed to be just at the point right here. What's the weather like in Maryland? So it's right over in this area. It's right on the cold front, so it's going to be raining. And how do you know it's right on the cold front? But don't worry about that one. We're just going to talk about the second page. Can you give the temperatures using this map? Why or why not? No. You could tell where it's cooler and where it's warmer, but you can't tell the temperatures using a weather map unless it's got the stations on it, and then you can start to see what the temperature is. Why is there no rain where the H is? So remember, high pressure systems are associated with clear, cool, dry air, so fair weather. So high pressure brings cool, dry air. They're sinking. Can't have rain. And what would the cloud cover be like if there was an L on the map? It'd be more cloudy because low pressure would be storms. Okay.
So it's high pressure, and the other one is
low
pressure.
Mm-hmm. High pressure is good weather. Low pressure is bad weather. All right. So that was the practice that we did together. Okay. All that you have left for class today, if you go back into the classroom and you just click on this last one, weather maps. This one, the pictures do work. Okay. So as we can see here, we've got a weather map, and all you're going to do is use all that information. You're going to kind of like combine this and put this into practice. So it's like talking about what is the weather like at this point? Well, look at what symbols are there. Look at what fronts are there, if there is one. Or, if the lines are close together or far apart, or things like that. But this is what the weather maps actually look like, and this is kind of how people determine what the weather is going to be. So again, for the first part, talk about what's the weather like at A, what's it like at B, okay, things like that. And then on the back, at the very bottom, you're not going to be able to draw on this map, so just list these as like what state. So you know, place a star where weather will be cool and dry. So just tell me what state. You can pull up a state, United States map, and that can help you with that state or whatever. Okay.
Okay.
But that's the easiest way that we can do this. Normally on a Wednesday, we would be in the building and you would have this in front of you in paper, so it wouldn't even be an issue. But unfortunately, there's lots of snow, so we're going to work with what we're working with. Okay. And this is what the turn-in is for today. This is the exit ticket and all. So this is kind of like showing that you were here and you paid attention to the lesson, and now you can work through it. Okay.
Okay.
So I'm going to stop the Zoom so I can start uploading the video for people who didn't make it on. But do you have any questions or anything like that before we cut off?
Not really about this.
Okay.
No.
Let me go ahead and